So this exercise related to the circular motion. The last session I explained the topic. Today I will solve the questions from this exercise. First 16 questions I have already solved. So we'll start with question 16. 15 I have solved. So in question 16, International Space Station, it completes 16 orbits of the Earth in every 24 hours. So every 24 hours, it completes 16 orbits, like move around 16 times. And the International Space Station is 330 kilometers above the surface of the Earth. Show that the angular velocity of the International Space Station, ISS, is around 1 exponent minus 3 radian per second. So what is the formula for angular speed or omega? Omega is actually like the rate of change in angle or how much the angular displacement changes every second. So it is angular displacement over time. Now, what about the angular displacement? Because when object move in a circular path, when it completes one orbit, like example, object start from position A and it move on a circular path and return back to this position A, what is the change in terms of angle? That is 360 degrees or equals to 2 pi radian for one complete. But it is completing 16 orbits. So what is the total angular displacement? 2 pi radian is for one, but because it is moving 16 times or completing 16 times, so this will be multiplied by 16. So 2 pi times 16, that will give us the total angular displacement. Then how much time it is taking? As I mentioned, it is taking 24 hours, but the final answer, we want radian per second. Like theta should be in radian and time must be in second. So time is given in hours. So we have 24 hours. So for 24 hours, first we have to convert into minutes. We multiply by 60, it will convert into minutes. And then minutes we have to convert into second. We multiply by again 60 to convert into second. So when we simplify this will give us 1.16 into 10 to the power minus 3. And the unit will be radian per second. Is it clear? The angular speed of the International Space Station, as it is completing 16 orbits. So one orbit, the angular displacement for one orbit is 2 pi, but for 16 orbit, it will be times 16. And the total time duration is 24 hours. So we have to convert into minutes. That's why first into minutes and then into second. That's why we multiplied by 60 and 60. The next part, calculate the acceleration of the International Space Station. The radius of the Earth is 6,400 kilometers. So the radius of the Earth is given. It is, for example, this is the Earth. The radius of the Earth is 6,400 kilometers. And the satellite or the space station, like this is International Space Station example, and that is 330 kilometers from the surface, as I mentioned, above the surface. So when we take a radius here, radius is always calculated from the center. So what will the radius? The radius is actually the sum of 6,400 plus 330. That will be the total radius or the total distance from the center. As we need an angular acceleration, so angular acceleration is having different formulas depending on which quantity we are finding. Like if for what we have, we can also use A is equals to R omega square, which will be much more easy to use here. So A is equals to R omega square, or there's also another A is equals to B square over R. But in that case, we have to calculate first B and then R by summing up and then find A. But in this formula, omega is already known, like we already calculated in part A. For example, if you are not able to get your answer, so you can use this value as for omega. So we have the omega, and what about the radius? So it will be the sum. You just add the two values. but that is given in kilometer. We have to convert into meter. So the radius is equals to 330 plus 6,400. So that is 6,730 kilometer. And we have to convert into meter. We multiply by 1,000 or 6,730, multiply by 1,000 or 10 exponent 3. So angular acceleration is r omega square. So r is 6,730 into 10 power 3. And omega we already calculated in the previous part, 1.16 into 10 power minus 3. And then square is there, so we'll just put in square. So this will give us about 9.7 meter per second square. That is the angular acceleration of the International Space Station. In question 17, hammer throwing in an Olympic sport. The sport uses a metal sphere which is attached to a chain. An athlete hold the chain and spin around to give a sphere a large angular velocity. As you can see here, when the sphere is released, it travels in a parabolic path through the air and it lands on the ground. Explain why at an instant of a release, the sphere stops traveling in a circular path. Like the moment athlete release, the sphere will not move in a circular path, it will move tangential to the circular path or a curved path. So what is the reason for that? Because whenever to move an object in a circular path, there must be a force. Like force is need whenever object move in a circular path, force is needed to change the direction. So the moment the athlete release this chain, so there is no force to change the direction. That's why it will move tangential to the curve path. So why instant like at the instant of release, the sphere stop traveling in a circular path because there is no force to change direction. And the sphere or the object will move tangential to the circular path or a curved path. So one mark is for mentioning because the moment he release, there is no force to change direction. So it will move in a tangential or to the circular path. A sphere has a mass of 7.3 kg. The athlete moves the sphere through a circle of a radius 1.7 meter. The speed of the sphere at an instant of a release is 18 meter per second. We need an angular velocity. Angular velocity means we need omega. Angular velocity refers to like what is the rate of change in angle or change in angle every second. Angular velocity, the main formula of angular velocity, that is theta divided by t. This is one of the formula, or we also have another formula that V equals R omega, where R is the radius, omega is angular velocity, and V is a linear velocity. This formula we normally use if we know the angle, like what is the change in angle and the time interval. But in this question, we don't have the change in angle. We have the linear velocity is there, V is there, and the radius is there. So we can use this formula to get the angular velocity. So V is given 18 here, R is 1.7 and omega is unknown. So 18 divided by 1.7, that will be equals to omega, which is equals to 10.6. So angular velocity is 10.6 and the unit is radian per second. Assume that both the circle and the chain are horizontal. Calculate the force that athlete exert on the chain just before releasing. So we want to calculate how much force exerted by the athlete. So simply we have to use this, like we have to find a centripetal force or calculate a centripetal force. How we can calculate? Because An object is there attached with a string or a wire or a chain, and still it is in contact. So the question is how much force is applied by an athlete. So when object move in a circular path, the force applied is equals to the centripetal force. Centripetal force is having formula F is equals to mv square over r, or it can be F is equals to mr omega square. So we have m here, what the mass is given. We have the radius r is given, and we just calculated the angular velocity. So we just like use the formula, substitute the value. So mass is equals to 7.3, radius is 1.7, and omega, the angular velocity, is 10.6, and then square is there. So F is equals to mr omega square. This will give us 1,390 newtons. Is it clear? Part B, 1 and 2. Anyone having a doubt or a question in this? Okay. Now in the next one, the diagram shows a sphere moving in a vertical circle. So look, in a vertical circle, when we work out, so this is a center. The weight is acting downward. So here weight is acting downward because it's a vertical circuit. Weight is acting downward, weight is acting downward. We need a centripetal force. We need a force to move the object in a circular path. And whenever force is applied, whenever we need a force to move the object in a circular path, if we are using a string or a wire, the force of a string or a wire is called tension. So here the tension is to pull the object. So tension is acting upward. Here tension is towards the center, and here tension is also towards the center. When we talk about the different positions are there, we have three different positions. We have X, Y, and Z. So at point X, if we want to write an equation, because centripetal force is a force which is directed toward the center. So the force which is directed toward the center, that is tension plus weight. So weight is also like directed towards the center according to position X. So it means we don't have to apply too much tension. The tension will be minimum at this point. Because like the sum of tension and weight is producing a resultant force, and that is causing a circular motion. So if we want a constant centripetal force, so sum of the tension plus weight must be constant. So if, for example, weight is 50 Newton, if we need a centripetal force to be 100 Newton, so if weight is 50, tension will be 50. If weight is 70, tension will be 30. So the sum of tension plus weight equals to centripetal force at X. At position Y, weight is downward, so it does not contribute to the centripetal force. So at centripetal force is equals to tension. Like what is the tension in the rope? That will be same as the tension at Y, because tension is directed towards the center, and that force is also responsible for circular motion. So centripetal force equals to tension. But for Z, what will happen? Tension is acting upward, weight is acting downward. So tension must be more greater than the weight, because we want the resultant force to be directed towards the center so that the object continue to move in a circular path. So tension minus the weight is equals to centripetal force. So in this case, at position Z, we have to apply maximum tension, or an athlete experience a greater force, or have to apply a greater force on the spring to move in a circular path as compared to position X. So the first part of a question, draw an arrow on the diagram to show the direction of centripetal force acting on each point. So what is the direction of the centripetal force? The centripetal force is always directed towards the center. Then tension in the chain vary as a sphere moves. State the position x, y, and z, which tension, like at which the tension will be maximum, and the position x, y, where it is minimum. So this is a derivation, a simple derivation is there. You can see which position we have a minimum tension. At position x, we'll have a minimum tension. Because to move the object in a circular path, the resultant force is tension plus weight. So weight is also contributing towards the center. That's why we don't have to apply too much force. But at position z, we have to apply force against the weight, and the tension must be higher than the weight to create a resultant force toward the center. So the tension will be maximum at position z. And at position y, the tension will not be minimum or maximum. It will be average or in between x and z. Is it clear? So centripetal force is a resultant force, and at x, all the position we want a resultant force towards the center, and at x, because weight is already towards the center, so we need minimum tension. But at z, weight is opposite to the resultant force. Like weight is downward, we want a resultant force towards the center or upward. That's why the tension should be maximum. Is it clear? Part C2. So if we sketch a graph, sometimes they ask to sketch a graph for different positions for resultant force or the tension example. So if we have like example, position X is there. If this is position representing position X, then we have position Y, then we have position Z. So at X, it will be minimum tension. At Y, it will increase, and at Z, it will be maximum. And then again, if there's another point, like example, A is there, so it will be smaller. And again, we reach, so this is at X, this is Y, Z, and A. So the tension we apply when object move in a circular path, it changes throughout the motion. The resultant remains same, but the tension changes throughout the motion. In question 18, a student holds a piece of a string with a small spherical mass attached to other end. She rotates the mass at a constant angular velocity in a horizontal circular path, which is below her hand. Explain why it is not possible for a student to rotate the mass so that the string is horizontal. Like, why a student cannot rotate this object horizontally in this manner? That's a question. So why she cannot rotate it horizontally? Because to rotate it horizontally, the weight is acting, like this mass will have a weight. And when this mass is having a weight, so when we are applying a force by using a string or a wire, so the tension is making certain angle with vertical or horizontal. So the tension will have the component. One of the component of a tension which is with an angle is balancing the weight, and one of the angle of the tension is directed towards the center, which is causing a circular motion. So the tension, like why it is not possible for a student to rotate this mass in a horizontal. So two reasons. What is the reason for that? Number one, because there's a weight acting. So if weight is acting, there must be a force which balance with a weight. And what is that force? That force is a component of a tension. If it was moving in a horizontal circle like this, if it was completely moving in a horizontal circuit, and the weight is acting downward, So, and the tension is directed toward the center. So there is no component to balance the weight. So it can never happen because there is a resultant force downward, and that resultant force downward will cause it to move in a conical path as compared to, or a conical pendulum as compared to a circular. Is it clear? Now a student now rotate the mass in a vertical circle, as you can see, moving in a vertical circle. So when it is moving in a vertical circle, when it is at position A, we have to apply a minimum tension. When it is at position B, we have to apply a maximum tension. So the string has a length of 25 centimeter. So this string is having a length of 25 centimeter. So this 25 centimeter is actually the radius, because the length is equal to radius when object is moving in a vertical circle, and is attached to a mass which is 204 grams. It rotates in a vertical circle, and the spring remain taut at all time, like it is continuing to move. When the mass is at the top, the force on the circle, it is moving on with an angular speed of 9.9 radian per second. Calculate the tension in the string. How to do this question? Like when it is at position A. So there must be a force which is directed toward the center. And there are two forces which are directing toward the center. So weight is acting downward, and there is a tension in the string that is also acting downward. So tension is also there and weight is also there. Like two of the forces, both of them are there. So tension and weight, and both are directed toward the center. So whenever object move in a circular orbit, the centripetal force is equals to the tension plus weight. And what is centripetal force? Centripetal force is given by mr omega square or mv square over r. Tension we don't know. And what is weight? Weight is mass into gravity. We need a tension, so we can say mr omega square minus mg is equals to t. M is a mass which is given in grams, so we have to convert into kilogram. Like it was 204 gram, so we divide by 1000, that is equals to 0.204 kg. Radius, that is the length of a string which was 25 centimeter. We divide by 100, so it will become 0.25. Omega, that is 9.9 square. That was given in the question, 9.9 radian. M, the mass again, that is 0.204 kg times the gravity 9.81, that will give us a tension. So when we simplify, this will be 5 and this is 2. So what is the tension? 5 minus 2, that's equal to 3 Newton. So 3 Newton is a tension in the string. And that will be the minimum tension. Like this will be the minimum value of a tension. When it will be on the opposite side, the value of the tension will be maximum. Is it clear, this one? If the same question was there, like example, if they ask the same question, the object is at position B and you need the tension. So here tension is acting toward the center, the centripetal force is toward the center and weight is downward. So we can say centripetal force plus the tension must be equals to weight. Or centripetal force is actually a resultant force. So you can also say that centripetal force is tension minus the weight. So in that case, centripetal force plus the weight is equals to tension. Centripetal force mr omega square was there. And this is a weight which is mg. So this was 5 plus 2. So in that case, the tension will be 7 Newton. So 7 Newton is a tension when it is on the opposite side. And 3 Newton is a, so when the object move in a circular path, In a vertical circle, the tension does not remain same. Tension vary. Like at this point, what will be the tension is equals to the centripetal force. Like we can say this was point C was there and point D. At point C and D, weight is acting downward. So the tension is a force which is responsible for circular motion. So centripetal force is tension. Centripetal force is mr omega square is tension, and the mr omega square is 5 Newton. So tension is 5 Newton. So here, different position, like at position A, we need a 3 Newton tension. At position B, we need a 7 Newton tension. Here we need 5 Newton, and here also we need 5 Newton. But the centripetal force will be same. Centripetal force is 5 Newton throughout, but tension vary as the object move from one position to another. So as the mass complete one circle, its position can be identified by an angle move using the angular displacement. One complete revolution means 360 degrees, and the tension is there on the axis below. First, as we just now solve that the value of a tension will be 3575. So we have now we have different positions. So you can take any position, like it's up to you, any position you can start with. Example, we are starting with a peak by like from the top. We are saying this is position A. So when it is at position A, the tension, it was like 5 minus 2, which was 3. So this was 3 at position A. Example, when it reached this position, so this was position B, the centripetal force is same, but the tension changes. So this was 5 Newton. So after 90, because like this is a 90-degree rotation, so at 90, the tension is 5. Then when it is on the opposite side, like it is at position C, the change in angle is 180 and the tension should be 7. When it is at position D, again the tension will be 5. And at 360, when it returned back, the tension will be 3 again. So when we sketch these points for a one complete revolution, like this was point A, this was point B, point C, point D, and then point A again. That's how the tension vary. But the centripetal force is same. All the position, the centripetal force is 5 Newton. Because that's a resultant force. But tension vary because the weight of this object is 2 Newton. Here the weight is acting like we want the total force, downward force to be 5. So weight is already 2 there. So how much tension we need? We need 3 Newton tension to get it 5. Here weight is 2 Newton, but that is not contributing towards the centripetal. That's why the tension should be 5 Newton, so that we get a centripetal 5. Here weight is acting downward, 2 Newton, but we want a resultant to be 5. So how much tension should be applied? So weight is equals to 2 Newton. The tension must be 7 Newton so that the resultant will be 5. And at this point, weight is acting downward, a weight of 2 Newton acting downward. So that does not contribute to the centripetal force. So we can say weight is 2 Newton. So tension must be 5 Newton, same as the centripetal force. Is this clear? The sketch for the variation of a tension. So tension changes, but not the centripetal force. Centripetal force is same, 5 Newton at all the point, but the tension changes as some position, the weight is directed towards the center of a circular path in a vertical circle, and some position it is opposing the motion. Is it clear, this one? Anyone having a doubt or a question? Moving on to the next question. The diagram represents a toy airplane on the end of a spring. You can see angle is there. An airplane follows the horizontal path of a radius r and the spring is at an angle theta to the vertical. Complete a free body force diagram. So in a free body force diagram, we represent all the forces which are acting on the object. So what are the forces acting? The weight is acting downward and there is a tension. And again, they can ask this, why this plane is not moving in a horizontal circle. So the reason is weight is downward, acting downward. So there must be a component of a tension to balance the weight. That's why it cannot move in a horizontal circuit. Like this plane can never move in this manner. It should always be in a conical pendulum. So free body force diagram, one is a weight, another one is a tension. The toy airplane completes 36 revolutions in 1 minute. Calculate the speed. So if you want to calculate the speed, we have V is equals to R omega is there, the formula. As we have, but this is revolution per minute. This is omega, but omega should be radian per second. So we have to convert the revolution into radian. One revolution, remember, is equals to 2 pi radian. And minute we have to convert into second as well. So multiply by 60. And the radius in centimeter. So we need V, that is R omega. First to get omega, 36 revolution. So it will be 36. One revolution like is equals to 2 pi radian. So 36 revolution will be 36 times 2 pi. Divided by the time interval. Divided by the time interval, it is 1 minute. So we have to convert into second. So we divide by 6. Actually, because it is theta divided by t, so time is in denominator. That's why the 1 minute multiplied by 16 denominator. So this will give us a value for omega. And V is equals to R omega. So we just substitute 2 pi into 36 times the radius. R is there, 0.4 and then 60. So this will give us 1.51 meter per second. That's the linear speed of this object. Is this clear? By considering the vertical and horizontal components of a tension, show that theta is independent of the mass of the toy. So this is a short derivation. You have to show that theta does not depend on mass of the toy, like theta will cancel out. So like if this is a tension, so tension will have two components, one with an angle, that will be T cosine theta, and the one against the angle will be T sine theta. So T sine theta is responsible for circular motion and T cosine theta balances with the weight. So we have two equations. T cosine theta, which is acting upward, balances with the weight, and T sine theta is equals to the centripetal force. We have to show that the theta does not depend on the mass. Like we will get a formula in which the mass will be eliminated. So we have these two equations. If I divide these two equations, like if I use T sine theta is equals to centripetal force divided by T cosine theta equals to W. So T will cancel with T. Sine theta over cosine theta is tangent theta. Centripetal force is mr omega square. and weight is equals to mg. So if m cancel with m cancel with m here. So what we are left with? We are left with tangent theta is equals to r omega square over g. So this shows that the angle or the theta does not depends on the mass of an object. So in exam, you will find these type of derivations, short derivations. Suggest how the value of a theta can be determined experimentally. Like if we do this experiment, how we can work out the value of a theta? There are different methods to work out. Like we can also use a video or a playback and then measure the maximum angle. We can do that as well. Or we can measure the diameter, this part, because like we can measure this whole part diameter, and then we'll find the radius from a diameter divided by half, and then we find the height, measure this height h, and then we can use a trigonometric, like this is making a right angle triangle. So this one is a perpendicular, here is the base. So we can use a tangent theta is perpendicular divided by base. So we can also work out the theta, that is tan inverse radius divided by height. So we can measure the diameter. First, we can measure a diameter. From a diameter, we'll find the radius and we'll measure the vertical height. Then take a tan inverse of this ratio of radius and height, we'll get the angle. That's how we can determine this experiment. Is this clear?